Hey guys, so we're back here with specific types of angles and angle relationships. So let's take a look at what happens when we have certain degrees of angles and angles combined together. So the first thing we're going to talk about is an angle bisector. So what is that? An angle bisector is a ray, or basically just two angles put together, but there's something special about them. As you see over here, what do we know? So we know that an angle bisector makes two angles congruent. That is, again, the symbol for congruent. So if we take a look at this diagram over here, it says that BD, so sorry for that typo, BD bisects angle ABC. So we have our big angle here, ABC. Again, an angle is formed by two rays with a shared vertex. And then we have this ray here that bisects this angle. So what do we have? Two congruent angles. So this angle here and this angle here are the same exact measure. So let's say the entire angle ABC was equal to, let's say, 80 degrees. That means that the two bisected angles, so angle ABC or ABD, is congruent to angle DBC, and their measures would be 40 degrees and 40 degrees. So main thing there is to remember congruent when bisected. Now on to the next diagram. So here what we have is we have two lines that intersect at a point. So we have line GH and line FE that intersect at point M. So what happens with this? This is what we call vertical angles. So it says vertical angles are congruent. So what angles are congruent here? I see four of them. So what angles are congruent here is the opposite angles. So this angle, and then these two angles here. Now, so that being said, for example, let's say angle HMF here is equal to 70 degrees. That means that angle EHM would be 70. So same thing goes for the red angle there, that pair of vertical angles. So if this angle is 110 degrees, this angle is also 110 degrees. So vertical angles are opposite angles that are congruent. Another thing you might notice here that we're going to get into is that two adjacent angles here add up to 180 degrees. So 110 plus 70 is equal to 180 degrees. So keep that in mind, as we will be talking about something to do with this later on. So for the next piece, we now have perpendicular lines. So perpendicular lines are two lines that meet to form a right angle. So we have line CD perpendicular to line AB here. So that means when they meet, both of these do create right angles. So 90 degrees and 90 degrees. And what do we notice again? We notice that these two added together is 180 degrees along a straight line. So right angles are congruent, obviously, because they're always 90 degrees. But we could also have a situation where two lines cross here like this, and we have four right angles. So keep in mind, if it says perpendicular, here's our symbol, it's equal to 90 degrees. Now, a specific pair of angles here is called complementary angles. Complementary angles sum to 90 degrees. Now, complementary angles can happen adjacent. They don't necessarily have to be adjacent to each other, but any two angles that add to 90 degrees are considered complementary. So let's look at this first diagram over here. We're told that this is a right angle, and we have some line that splits up this angle. Now, it doesn't necessarily bisect it, but it's a line or a ray that makes this angle split into two. So whatever these two angles are, add to 90 degrees. We don't know that, but we can tell that they're complementary. Now, for this instant here, these might not be adjacent angles. They do not share a common vertex, but both of them together, if we're looking at them, they do add to 90 degrees. So they are a complementary pair of angles. Now, one way to remember this is, say we have the letter C. You could draw a 9 from this from the letter C. So what you do is you draw a 9. That helps you out. So 90 degrees is the key with complementary angles. So now we're going to take a look at supplementary angles. So instead of adding to 90 degrees like complementary angles do, supplementary angles sum together to 180 degrees. So what we have here is, again, like something I brought up before, two angles along a straight line. So something we talked about earlier, last lesson, was a straight angle. So there is an angle created by a straight line, believe it or not. This is 180 degrees. So now we have two actual angles built off of this. This is called a linear pair specifically, but these two angles are supplementary, and that's known because it's two angles off a straight line. So now here we have two angles. Say this one is 110 degrees again, and this one's 70. Those are supplementary because they both add to 180 degrees. Now, they're not adjacent. They're just two random angles in a picture. That doesn't matter. As long as they add to 180 degrees, they are supplementary. So let's move down to number 6 here. This is what we call consecutive angles. So again, as I was just saying, they're along a straight line. So we have 1, 2, 3, and 4 angles together. They do add up to 180 degrees. So this one could be 40, this one could be 50, this one could be 30, this one could be 60. They are consecutive angles on a straight line that sum to 180. So we could have 100 angles along a straight line. As long as they're on that straight line, they're all going to add up to equal 180 degrees. And now finally, we look down at angles at a point, which sum to 360. So angles at a point, we have here, here, and here. I like to think about this as a circle. So in a circle, we have a total of 360 degrees. So when we have angles that go around a point like that, they all have to add to 360. Now we're presented with some practice problems based off of identifying the angle definitions we just spoke about. So if you want to practice these, go ahead and pause the video, and when you're ready to go over them, you could go ahead and restart it. So in the first image here, so this problem A, it says this angle is 36 degrees. Now we have to find the measure of angle X. So what kind of situation do we have here? Well, this is a vertical angle picture here. And what do we know? We know that vertical angles are congruent. So that means that angle is also 36 degrees. Now for B. B, we have two angles along a straight line here. So two angles along a straight line do sum to add to 180 degrees. They are supplementary angles. And this is also a linear pair. So what do? To solve for this, we do 180 minus 121, and we get that angle Y is 59 degrees. And now for C, we have three angles here, and this is not a straight line, and it doesn't look like supplementary or complementary. What we have here is angles about a point. So again, remember 360 degrees total. So what we have is 82 and 172 and angle Z. So if we add up 172 and 82, we get 254. Then what we do is we subtract 254 from 360, and we get that this angle measure is 106 degrees. So moving on, we once again have to find the labels or find the measures for the labeled angles here. So if we take a look, angle A, again, is along a linear pair. So this is going to be supplementary. So let's go ahead and take care of 180 minus 145. And there we get angle A is 35 degrees. Let's go ahead and look at angle B. Angle B is in one of those vertical angle diagrams, but we only know this angle here. So yes, we know that angle C is 40 degrees because the opposite angle is the vertical angle and they are congruent. So we can answer angle C. But technically for angle B, the way we know this is because this is also a linear pair. So if we trace this part of the picture, we have just a straight line and two angles. And like we said before, two angles along a linear pair are supplementary. So yes, we do have to add them to 180 degrees, and 140 plus 40 will give us that 180. So angle B is 140 degrees, and technically the way we found that was because it is a linear pair. Now that we have angle B, we also get angle D. It's another vertical angle situation. Again, vertical angles are congruent. Finally, off to angle E. If we had to look at this here, we're looking for this angle presented here. So actually we're looking for the total angle. How are we going to get the total angle? Well, we have to break this picture apart first. So we have our straight line here. So immediately, what do we know about this piece here? What we know is that it's a straight angle. So a straight line has a measure of 180 degrees. But now how do we get this piece? What we have to do is do 180 minus 122, because this is along a straight line and it's a linear pair, so it's 168 degrees. Now, if we were to go and add these two, 68 degrees. So if we add 68 and 180 and 68, we get 248 degrees for angle E. And that is because this is a combination of straight angles as well as a linear pair. So now, fill in the blanks. Two lines are perpendicular if they form right angles. So perpendicular lines would be two lines that cross and create right angles. And then finally for 4, if two lines are intersecting, then they form blank angles, which are blank. So if two lines are intersecting, just two random lines, we don't know anything else, they intersect at a point, this is where they form vertical angles. And what do we say about vertical angles? They are congruent. So that would mean that these two angles are congruent, and then these two angles would be congruent. Okay, moving on. So use the figure to the right to answer each question. So we have a combination of questions here about angles in this diagram. So we have, looks like two perpendicular lines and just another line intersecting them. So let's see what we have. So for A, it says if ray XE, so let's go ahead and take a different color and highlight XE. That would be this right here. Bisects AXD. So that means if it bisects an angle, those two angles that it created are congruent. So angle 2 and angle 3 would have to be the same measure. So we can say now AXE, so this angle here, and DXE are congruent. For B, name a pair of perpendicular lines. So perpendicular lines are two lines that intersect to form a right angle. So if we go ahead and erase this, where do we see a right angle? We see it here. So obviously that means this is a right angle as well. So the two lines that we have is line AC and then also we have ray XD. So remember, it's a line and a ray. So name one right angle. We just did. Here's one of my right angles. That would be angle DXC. Name a pair of vertical angles. So vertical angles are two angles that are formed by intersecting lines at a point. So where do we have that? Well, I see two intersecting lines here that aren't perpendicular. So a pair of vertical angles could be angle 2 and angle 1. or we can work with these two angles here. I'd rather work with angle 2 and angle 1, just because this is a combination of two angles, and it might be a little confusing to name. So let's go with angle 1 and angle 2. So now we have to come up with a pair of complementary angles. Complementary angles are two angles that sum together to 90 degrees. So earlier we said that these two lines were perpendicular. So that means it forms two right angles, which are 90 degrees. We also said that this segment here bisects, or this line here bisects this angle that adds to 90 degrees. So that means if this is 90 degrees total, these two angles have to add to that. So angle 2 and angle 3 would be complementary. Now, let's go down here, a little bit of a trickier question. We have to come up with exact angle measures based off of what we're told. So it says, what is the measure of angle AXE plus angle AEXD plus angle DXC? So we need to find a total measure of three angles put together. So let's first highlight the ones we're looking at. So angle AXE, we need this angle. Angle EXD, which would also be this angle, and angle DXC, which would be this angle. Not as confusing as we thought. We have a bunch of angles along a straight line. So what we have here is a bunch of consecutive angles, or just a bunch of random angles along a straight line. And again, a straight line, no matter how many angles you put on it, will always have a total of 180 degree measure. So it is 180 degrees. Now, if we move on to the last question here, it says use the following diagram to answer the questions below. If angle HZJ is equal to 38 degrees, what is the measure of FZG? So look at that. You'll start to pick up on these a lot quicker. This is, again, a pair of vertical angles. So it's all it is just congruent. So we have 38 degrees for that measure. So let's go ahead and look at the next one. HZJ is now equal to 38 degrees. So again, 38. Now we're looking for angle HZG. So HZG would be this angle here. So we have two angles along a straight line or a linear pair, so they are supplementary. So we do 180 minus 38, and we do get 142 degrees. So on to the last one. Again, it's 38 degrees. We are looking for angle AZJ. So AZJ is this angle right here. So here we're told that this is 90 degrees. So based off of that, that means we should be able to tell that these two lines are perpendicular. So if this side's a right angle, then so is this side. So that means this total angle is 90 degrees. So to get the missing angle, AZJ, we have to do 90 minus 38. So if we do 90 minus 38, we do get 52 degrees. Here is our missing angle. Last question. In the figure given ABC, so line ABC, what is the value of x? So we have 1, 2, 3, 4, 5, 6 angles here along a straight line. So no matter what, all of these angles have to add to 180 degrees. So we already have that this one's 20. So now we have 160 degrees to make up between the rest of these. So we have 1, 2, 3, 4, 5 now. So what we do is we do 160 divided by 5. And we get that each angle here is 32 degrees, and they are all congruent.